Rational functions part 1a. We use part 1a because part 1 is actually the title of this objective 7. We're going to graph rational functions. One of our objectives is to find a picture of this function, but we're also going to work in some limits. We're going to have multiple parts to this video series for objective 7, so we can break it down into relatively small pieces. Well, first of all, speaking in generalities, we have a function f of x equals ax plus b over cx plus d. We have what's called a horizontal asymptote. That's this right here. It's a horizontal line, and the function approaches it from above this way, below this way, or possibly flip-flops, depending on the signs. It gives us an idea of what the long-term steady-state behavior of this function is. And we just calculated as y equals a over c, this number over that number. We'll talk about y in a minute. And we have a vertical asymptote. That's this vertical line here. From the right, it approaches it going upward. From the left, it approaches it going downward. It gets closer and closer without ever touching it in this case. And we just calculate x equals negative d over c. This comes from a 0 in the denominator. If you set this equal to 0 and solve for x, it gives you negative d over c. And it basically, when the denominator approaches 0, it shoots off to positive or negative infinity. It becomes indefinitely large. So in this particular instance, we have f of x equals 1x plus 2 over 2x plus 3. We can calculate the horizontal asymptote, which I'll abbreviate. It's just simply y equals these two numbers, 1/2. And then we can calculate a vertical asymptote. And if you want, you can just, this process gives it some meaning. Set 2x minus 3 equal to 0. We get x equals 3/2. There's two pieces of information. Now, the interesting question is, why do we have these? So let's just spend a minute making a table. X, f of x. And as far as the horizontal asymptote is concerned, I mentioned we're looking for what's happening at the extremes. X gets large, and x gets large in the negative sense. If you plug 10 in, for instance, you end up getting 10 plus 2, 12 over 17. If you plug 100 in, 100 plus 2 is 102 over 200 minus 3 is 197. And if you look at it, that's probably close to 1/2. And if you plug 1,000 in, what happens? Well, guess what? I'll write this out a little more explicitly. You have 1,000 plus 2 over 2,000 minus 3. And guess what's happening? This 1,000 over 2,000 dominates. The 2 and the 3 are really fixed while these two numbers grow. And that's going to be approximately 1/2, even closer to 1/2. Gets closer and closer to 1/2. Well, guess what? This is what is important. You could ignore the 2/3 and just 1x over 2x is really 1 over 2. You can plug in a negative number, the same thing happens. Just have negative over negative, which is positive 1/2. Now, if we want to look at the vertical asymptote, and that's what's happening. X equals negative d over c. In this case, it's x equals 3/2. We're getting closer and closer to 3/2. Well, if you try to plug 3/2 in, first of all, it's undefined. You end up getting 2 times 3, or 3/2 plus 2 divided by 0. 3/2 plus 2 is 3/2, and 4/2 is 7/2 divided by 0. It's undefined. Okay, so there's no point there. Let's back off a second. If you plug in 1.4, That's close to 1.5, or right about here. And plug 1.4 in, we end up getting 1.4 plus 2 over 2 times 1.4 minus 3. And that's equal to 3.4 divided by 2.8 minus 3 is negative 0.2. And that ends up being negative 17 if you divide it out. Okay, so we're headed downward. Okay, or just to the left. If you plug in something like 1.49, that's even closer to 1.5. 3 halves is 1.5, by the way. So if we get even closer to it, we have 1.49 plus 2 over 2 times 1.49 minus 3. And that's 3.49 over, that's 2.98 minus 3, negative 0.02. You can divide 349 by 2, and that gives you 174.5. Okay, and that gives you 174.5 in the negative sense. Negative 174.5. Okay, and you see what's happening. It's headed to negative infinity. We can make this closer, and this will get closer still. If you move in from the right, it's just going to be positive instead, and it goes up in the positive direction. So this is a numerical reason why these asymptotes exist. So now the question is, that's explanatory. That doesn't really solve the problem for us. Suppose we want to graph. This is what you'll do in your packet. We're going to put 3 halves in the middle. And that part is undefined. And that's a dividing point. This vertical asymptote right in the middle, we want to pick a few points to the right, a few points to the left. And so to the left, you can count back 1, 0, negative 1, count forward 2, 3, 4, and that will give us enough to draw the graph. We're really just trying to decide where these parts are. We already have the asymptotes established. We substitute negative 1, we get negative 1 plus 2 over 2 times negative 1 minus 3, 1 over negative 5. And that's negative 0.2. If we substitute 0, that drops out. We get negative 2/3. I'll just say negative 0.7. If you plug 1 in, we get 1 plus 2 over 2 times 1 minus 3, 3 over negative 1, which is negative 3. Okay, that should be enough to place our graph. Now if we substitute 2, we get 2 plus 2 over 2 times 2 minus 3, and we get 4 over 1, or 4. This is just computation. You can even use a table function on a calculator for that matter. 3, plug in 3 plus 2 over 2 times 3 minus 3. 5 over 6 minus 3 is 3. We'll call that 1.7. 1.66 repeating. And substitute 4, you get 6 over 5. 6 over 5 is 1.2. I'll do that one in my head. Now the question is drawing the graph. I'm going to make a coordinate system. And we need y to go from -3 to 4, x to go from -1 to 4. Let's make my y coordinate a little bit bigger. 1, 2, 3, 4, 5. 2, 4, 1, 2, 3, 4. Yeah, okay, I'll just put, the scale doesn't have to be uniform, but in this case it's definitely possible. Sometimes these things get pretty, shoot off to infinity pretty rapidly. So we have the asymptotes, y equals 1/2. That's right here. And we have the vertical asymptote, x equals 1.5, x equals 3/2. That's right here. And then we're going to plot some points. We have at -1, we have -0.2. That's right about here. And at 0, we have -0.7. You can see we're rounding the corner. At 1, we're at -3. And it rounds the corner and does this. Okay, it should be a little smoother than I have, but my sketching skills are a little bit limited. Nice piece of graph paper might help. And then we move to the positive side. At 2, we're all the way up at 4. And at 3, we're down at 1.7. That's below 2. And at 4, we're at 1.2. You can see we're already closing in on the asymptote. And there's our graph. That's really all there is to drawing the graph. That's the end part 1A. Part 2, we're going to talk about limits. So we'll do that in a separate video. That's all for this video.